Since before recorded history, people have been using wheels to move their possessions. Just some wheels and a box was good enough for centuries. But today, the loads are greater and the speeds are much faster. In order to handle these increased demands, modern vehicles need suspension systems. The intent of this video is to familiarize you with the principles of wheeled vehicle suspension systems. Reference is made to several different types of vehicles throughout this tape. You may or may not work on all of these. On the other hand, you may work on others that do not appear in this presentation. For detailed descriptions and explanations, consult each vehicle's technical manual. There are a number of different suspension systems. However, they all have several basic components in common. First, of course, are the wheels, usually joined by an axle. The axle is attached to the vehicle by some sort of spring. You also need shock absorbers to control the spring. Finally, the system must be located and secured on the vehicle by some means. On modern vehicles, attached to the chassis are flexible couplings called springs. The springs are there to make sure that the wheels maintain good contact with the ground at all times and to minimize road shocks to the chassis. Coil springs are made from a rod of high-grade steel twisted into a cylindrical shape. If this cylinder is compressed, it will return to its original shape when the pressure is removed. Coil springs do not produce friction in use, so a shock absorber is necessary for control. Leaf springs are made from curved pieces of flat steel. These, too, will return to their original shape after bending. You can stack several together for greater strength. They are bolted in the center and have clips to help hold them together and in line. As the springs flex, there is friction between the leaves, which helps minimize oscillation. In use, the center of the spring is usually attached to the axle and the ends to the frame. This connects the wheels and the axles to the vehicle. Since the spring changes length as it flexes, one end is held in a hanger that allows it to pivot, and the other in a shackle that compensates for this movement. In cases where heavy loads will be carried, the springs can be made progressive. That is, they become stiffer as the load increases. Otherwise, they would have to be too stiff for those times when there is little or no load. Another way to achieve progressive spring action is to arrange a single set of leaf springs so that the center is clamped to the frame of the vehicle and the ends rest on, but are not attached to, two axles. As the springs flex and the ends extend beyond the axles, their effective length becomes shorter, which makes them stiffer. An example of this arrangement is found on many Army trucks, such as the 2.5-ton or 5-ton. Once a spring has been set in motion, it tends to continue oscillating for some time unless it is restrained. Stopping extra oscillations or damping the spring is the job of the shock absorber. There are several types of shock absorbers using gas, air, or oil as a damping medium. The most common is the oil-damped or hydraulic shock. This consists of a closed tube that contains a piston. The tube is filled with oil. When the piston is moved in one direction, the oil is forced through a small one-way valve in the piston. When it is moved in the other direction, the oil must flow through another one-way valve. The amount of effort it takes to move the piston is determined by the size of the valve. Since there are two different valves, you can make the damping effect different for each direction of movement. Thus, you have a double-acting hydraulic shock absorber. The degree of damping is set at the factory and cannot be adjusted. There are several ways to mount shock absorbers. They can be placed between the axle and the frame, for instance, or between moving elements of the suspension. Another job of the suspension is to maintain the wheels in their proper place on the vehicle. The only movement allowed is the up and down movement in response to ground conditions and turning movements of the wheels that do the steering. The leaf springs will also perform that function acceptably. Other vehicles need additional positioning braces. These might take the form of a stabilizer bar, as on this vehicle, or torque rods, as used on double axle rigs. These braces not only position the axle in the frame, but they also resist the tendency of the axle to rotate with acceleration or braking. The key element in all suspensions are the wheels and axles themselves. There are a number of configurations that are used on military vehicles. The simplest arrangement is the dead axle. This just consists of a steel beam or tube with a wheel at each end. It does not provide any driving force. Some trucks have this arrangement in the front. A more common type in the military is the live axle. This is similar, except equipment has been added to drive the wheels. A good way to relieve the load on the axle is to divide it between two axles. You can do this with either a bogie axle, as on the 2.5-ton truck, or an equalizer beam suspension, as found on the Hemet. In both cases, the two axles are allowed to rotate on a central pivot point on the frame. The load is thus divided between the two axles. The geometry of the arrangement also means that the springs and frame are only deflected half as much as the wheel when it reacts to a bump or a hole. There is one suspension system that doesn't have an axle. That is the independent suspension. The wheels are positioned by upper and lower control arms with coil springs and shocks attached to the lower arm. This is the type of suspension used on the Humvee. It provides excellent tracking over rough ground. Some vehicles can add another axle when they need it to help with heavy loads. It is called a pusher axle and is pushed into position by compressed air entering a rubber suspension bag. The air pressure in the bag serves to hold the wheel against the road. The job of the suspension system is to support the weight of the vehicle in a way that allows it to operate safely at different speeds over a variety of surfaces. Proper servicing and maintenance of the various components is covered in detail in your technical manuals. Suspension systems are rugged and reliable. With proper care, they will get you home every time.